And I wouldn't want to do this. This is not how I'd want to figure out if this is evil or not. So we hook another function, which is the parse script text core. And that's anytime the script interpreter is going to run a script, it's going to first load the script. So if I've hooked that, then I get this nice output here. Wow, that's much easier. That definitely looks malicious to me. It's loading Adobe stream, or ADO-DB stream, shell application, and it's also loading this class ID, which is Mtac. Now, I don't know how familiar you are with the Mtac exploit. It's brain dead. In order to exploit a machine with this version of Mtac installed, load the Mtac control. That's it. Once you've loaded the Mtac control, your privileges have been escalated to local system. You can run whatever the heck you want. So fun stuff. And you'll notice even at this level, after they've obfuscated the main blob, they'll still resort to these really trivial kind of concatenation type obfuscation procedures. So I think that's a pretty clear example of what a script being completely torn apart by the techniques we're talking about. And lastly, I want to show you the malicious download because we also hooked the network layer. I know I didn't talk about that. But here's the actual executable that got pulled down as part of that ADBO stream, and it actually launches. So based on all of that, you'll see the following heuristic and static detections. So it's telling us there's an ActiveX control with a well-known exploit vector loaded. No kidding, MDAC. It'll also tell us that we instantiated two controls that are unsafe for instantiation inside, i.e. that violates the sandbox. There's no way you should have access to the shell directly from JavaScript. Lastly, the behavioral detections. These are the key. It actually pulled down that mwd.kfe as probably a random garbage.exe, and it attempted to launch it with a shell.execute. So torn apart, if you had to do that by hand, you probably could have. I could have probably manually done this. I wouldn't want to, but I could have. So let's move on to the next one. Ooh, don't do that. This is exploiting a vulnerability in the Java development kit. And I'll show you the very first part of the script. Nasty, huh? So far all we've got is arrays upon arrays of numbers. That doesn't do me any good. How do I figure that out? So I'm going to keep scrolling, and there's a lot of it. So these people really, really did not want you to read their script. They bent over backwards here, ironically making them easier to spot because this level of obfuscation is silly. So the first thing I see is a bunch of arrays with numbers in them. The highest number I saw was 127, so it's probably ASCII. Then I see a whole bunch of for loops going through each one and performing, I think that's an exclusive OR. My JavaScript is non-existent. That's an exclusive OR. Based on the context, I would say that's an exclusive OR with 19 of the first array. So it's iterating through, taking all those numbers, exclusive ORing with 19. Likewise for each one of them, and it has a different number for each. Well, starting to get painful, huh? So we keep going down, and eventually it's going to go take all of this stuff and write out a blob to the eval function. Now, how do I know that's the eval function? Well, this garbage variable name is a combination of these garbage things, and it's going to spell out eval if you do the math right there. Another obfuscation technique that really jumps out here is all these variable names are randomly generated, again, to destroy any kind of static analysis you want to do. So if I load the script again, all of the variables, all the function names will be completely different. And this is another layer of obfuscation. It's assigning this variable to the window. It's referencing the eval function from the window and then invoking it through some extra char code and other layers of obfuscation. And again, they're breaking up the strings to avoid static detection. So pretty nasty stuff. I can't do anything with that. I don't think anyone could. If you wanted to manually reverse that, it would take a very long time. So partial de-obfuscation. These guys weren't happy with one layer of really nasty obfuscation. They used two. So de-obfuscating all of that, I get this large blob of text, stuff that starts looking more like things I can read. Those kind of look like class IDs, maybe. I don't know. And on and on. So this is a giant blob of text that they go, iterate across again. And I'm not going to try to follow all of this. But eventually all of that will be evaluated down into something that the script interpreter can understand. And we'll catch it later there. But I will point out it's actually browser aware. It'll fingerprint you and serve you the exploit that is appropriate for your browser OS combination. So it's going in, saying, is this Opera? Is this Gecko? Really, Gecko? Is this Safari? Is it Chromium? And it'll serve you the exploit that is tailor-made for your browser. So let's peel away one more layer of obfuscation. So the very first thing that jumps out at me is, I can read this. We've peeled off enough layers, we've hooked deep enough into the render engine and the script interpreter to figure out what it's actually doing. So the first thing I can see is, oh, it's got some sort of link somewhere, and that looks like an object invocation try-catch block. It'll basically let you attempt multiple different ways of instantiating any random object you feed into it. And it's got all the nice randomly generated variable names because those 2 layers of obfuscation that they had at the beginning weren't enough. And as you'll see here, the actual exploits get listed down here, and they're still doing the same thing. So eventually this is going to result in a get, and the JDK attack, we see the classic Mtac attack. So this is an entire exploit kit. The Mtac attack will be launched 200 milliseconds after you hit the page. So there's a script lock that's waiting for a timeout before executing. If that doesn't work, at 1 second in, it will attempt the JDK attack, which is basically a pointer to the Java compiler, but instead of passing it a local jar file, it's actually passing it a remote jar file. And we can look at that right here. So basically I can go point this at whatever server I want, feed it any jar file I want. The JDK will compile it and run it with system privileges. So bang, instant exploit. And there's a few other ones here. This is a JavaScript JSB attack, and I actually don't know what that one is. I'll have to look that up later. And there's the classic, I'm going to load PDF exploit into IE attacking the Adobe plugin. So in this particular case, actually, two of those exploits actually worked in our VM. We detected the attempts, but 2 of them actually exploited us. They dropped updates.exe and a.exe and launched them. And again, we have our heuristic and static detections. So fun stuff. And I need to stop hitting escape. The last one is actually a pretty recent vulnerability. This is in the help control inside the Windows operating system, the HPC protocol. And I wanted to bring this one up because it's not linking. Because this one actually does a few layers of redirection before hitting you to this exploit. Not sure why the link isn't working there. I'm not going to stress about it too much. But what it basically shows is instead of going directly to the script page, it's going and bouncing off like 10 different servers first before finally hitting the exploit page. And it's a little bit trickier. After it exploits you, it jumps you away to Google 404. And this one's pretty selective. And we can see the very simple HPC exploit here, which is basically a buffer overrun on the script parser. And it is also an exploit kit, so it's going to try multiple different ways of owning your browser. And again, the detections. I won't bore you with the details, but obviously it tries to launch an executable. Ooh, here we go. Let's hope my VPN's still up. So earlier today, I grabbed about 2,000 pages that were known malicious within the last month or two, and I'm going to feed them in here. And chances are only a handful will still be malicious. A lot of these scripts are very short-lived. Domain entries get pulled, websites get cleaned up, And fair warning, I didn't make any attempt to screen these, so if pornography comes screening on the screen, I'm sorry about that. Just close your eyes. So here's the text file, basically filled with all the URLs that I pushed out. And it's very simple. We have a web interface. I was hoping that I would have a full nice UI to show you, but you're going to get the debug UI because I can't write UI to save my life. And we'll try to go ahead and submit that. So I've submitted the scripts. In this deployment, I have 96 virtual machines, all waiting to plug away. So that's about 2,000 URLs. I'll get through that in about a minute, a little less than a minute. And I've only got 3 of these up here right now, and you'll see that it's launching browsers, going to particular pages, and logging everything that happens during the render process. Now, at the very first, they're going to take a little bit to render, but rest assured, it renders all the way through. One of them actually links me directly to XML, so who knows what this is going to get. So random web pages, off we go. Neptune's doing its thing. It's producing megabytes and megabytes of log files. It's keeping the ones that violate any of our rules in terms of behavioral, static, or heuristics. And we'll get to look at the output of that once it completes in another second here. Really? So I'm going to look at the detections page. And this is basically just giving me the list of the detections that I just found today of the ones that I just loaded up. I'm not going to try to do a reverse on the fly here because I don't know what this data looks like. Some of these can get really, really large. But I do want to prove to you that all of the stuff that you saw on the slides was done in an automatic fashion. There was no hand munging any of that. That's just raw data from these interfaces. And if you look, the font's the same. I just cut and paste into a PDF just to make it easier for the demonstration. Is that legible? There's nothing I can do about it, so hopefully it is. So I'm going to try to find one which I know is cute. There it is. So here are the behavioral checks that happened. We only keep the log files if we trip on something. So I know that this guy tried to launch a file to .// which makes it a couple of directories up, file.exe. So it went and pulled this down, tried to launch that. So right there, that's conclusive that this is a malicious page. I also have heuristic detections, and I also have reputation sources that, where it pulled stuff down was from a site that's on the bad list from Google or Trend or various other reputation sources. It's not really pertinent to this talk, but it is a powerful add-on that you can just throw in there because you've got all of this data hooked in. The nice part about being this low into the operating system, I know exactly what traffic went back and forth. So if they try the redirection games, no problem. We know exactly where every piece of that script, every piece of that HTML came from. We can track it back, and we can replay at will any of these attacks. So if I see the attack once, I can always verify that it's going to happen, and I can always replay it as a form of proof. Now that's actually a key point in the malvertising scenario, because any DoubleClick, Ad Center, Google, they're like, oh, we never serve malware, and good luck trying to get them to admit that they may have served a piece of malware. This is definitive proof. This is where the exploit came from. It was from the ad iframe. So we also log, before I get into the script, so the raw HTTP traffic, so I know everything that came across the wire. Now, you'll notice this one went directly to the site, scotty.net. Not sure it's going to do this, but this one gives me a lot of trouble because it will only serve me malware once a day, once every n hours. I don't know what those n hours are. So I'm going to rescan it and show you what it does in a little bit. I'm going to rescan it and show you what it does now that it's served me one piece of malware. But before we do that, let me prove that all of the dissection stuff happens automatically. This is what the script originally looks like, not human readable. This is what it evaluates down to. Further down I go. This is just a raw dump of what we see from the instrumentation within the JavaScript interpreter and the DOM. And eventually we'll get down to the point where I can see human readable code. This is an exploit kit. Here's trying to attack Flash. It's using a heap spray. It's detecting my version of Flash and tailoring the actual attack to the version of Flash that I have. It's also going to launch a PDF exploit Flash 10 exploit, the list goes on. And it looks like it's also going to do IE peers. So